My name is Nazatul Ashikin and I will be explaining about the volumetric flask. A volumetric flask is a pear-shaped glass flask with a long, narrow neck and a single calibration mark that measures what exact volume of liquid with high accuracy. It is commonly used in a volumetric analysis to prepare standard solutions and perform accurate dilutions, ensuring a reliable and precise
Next, I will be
concentration explaining
measurements.
about the importance of volumetric flask in our everyday industry. From this slide, it is shown that the importance of volumetric flask in different industries. They are used in pharmaceutical quality control, environmental testing, the food and beverage industry, and research laboratories. In all these fields, volumetric flasks help prepare accurate standard solutions and dilutions, which ensuring reliable and precise
Now,
analytical
let's look
results.
at the research behind volumetric flask. This study was conducted by Nagarnaik, Sajoshi, Bokhe, and Pandya in 2015. The researchers wanted to find out whether laboratory equipment such as volumetric flash, pipes, and burettes actually delivers the volume staged by the manufacturer. Their research question was simple: do these measuring instruments perform within the manufacturer certificate tolerance after considering both systematic and random zero? To answer this, they calibrate different size volumetric flash including 5, 10, 25, and 100 milliliters. Using the gravimetric method, they then calculate the systematic error, random zero, and the overall measurement and the accuracy of this volumetric flash. The research used the gravimetric method, which measuring volume by weighing water instead of relying on the gradation marks alone. First, the flash was cleaned, remove any residue. Next, the with the empty flash using a high precision balance. Then the flash was filled with distilled water until the bottom meniscus touched the calibration marks. After that, the flash was weighed again, and the difference between the two measurements gave the mass of the water. Since the water density changed with temperature, they correctly the measurement using water density tables to convert the mass into the actual volume. Finally, they compared the measured volume with the nominal volume and repeat the experiment several times to calculate systematic error and random error.
Result 1. Uncertainty grows with flask size. What the data shows here, the 100 flask carries the largest absolute uncertainty, which is plus minus 0.23 milliliters, about 9 times the 10 milliliter flask. This is expected. Larger volumes means a larger surface area at the meniscus and more water mass to weigh, both adding error sources. Even small uncertainty matters in trace level pharma or environment work. 0.2 ml can shift a result outside spec. Bigger isn't always proportionally better. Same data expressed as percentage of the flask's own nominal volume. As you can see here, the surprising pattern, the 10 ml and 100 ml flasks were proportionally the most precise in a range of 0.23 to 0.24%. The 5 ml and 25 ml flasks were proportionally less precise in the range of 0.52 to 0.56%, despite being mid-range sizes. So the takeaway here, precision doesn't scale neatly with size. Each flask should be evaluated on its own calibration, not assumed from its volume class alone.
So, did the flask pass manufacturer tolerance? The answer is yes. This is because all the 4 volume tested from 5 to 100 milliliters, our measured errors were below the certified limits. Hence, all of the flasks passed our independent testing. However, please note that the distinction at the bottom, whereas passing tolerance does not mean having zero uncertainty. These flasks still carry a small, measurable uncertainty that we must account for in highly sensitive
This means
analytical
that
models. Regulated industries can't ignore this. This is because in pharma and food QC, even sub 0.3% uncertainty must be documented and accounted for in reported results. Any errors could be controlled or prevented with correct technique, whereas cleanliness, meniscus reading, and temperature control were the main uncertainty sources identified and all controllable by the analyst. Regardless, regular calibration still matters. Class A glassware reduces but doesn't eliminate error. Hence, periodic re-verification keeps result
In
trustworthy over time.
conclusion, the volumetric class is a sample but is a foundational. It underpins nearly every quantitative result in analytical chemistry. Gravimetric calibrations show real flaws result with the manufacturer tolerance. Confirm apparatus pathology when properly used and maintained. But measurable alternatives still exist, but doesn't scale simply with flask size. Each piece of glassware deserves its own certainty. In regulated industry, the small alternative is exactly why calibration technique and documentation are non-negotiable.